Good morning, ma'am. Okay. In the last class, we have seen pigeonhole principle. What is pigeonhole principle? It is simple that we will be having n pigeons and m pigeonholes. Okay. In order to place n pigeons into m pigeonholes, we will be having what you call alternatives like m alternatives for the first one. For the second one will be having m minus 1, like that we can consider. Finally, suppose if n is greater than m, then definitely after filling all the pigeonholes with one pigeon for each pigeonhole, we will be left with at least one more pigeon. Then that has to be placed in one of the pigeonholes where we have put already one pigeon into it. So what is the consideration is, no, what is the observation that we can claim from this particular one is at least one pigeonhole contains two or more pigeons. Whenever n is greater than m, then at least one pigeonhole will contain more than one pigeon. Okay, that is what the conclusion that we can draw from this particular case. Whenever n is greater than m, then only that is the case. For example, let us argue like n is less than m. Can we say anything about it? If n is less than m, can we say? Yeah.
No, sir.
uh, we could say try it. We could say, I'm saying something can be what you call guaranteed. What can be it? If n is less than m, that is less number of pigeons we have compared to the number of pigeon holes, then what we can guarantee?
Every hole may contain one pigeon.
At least one hole will be
uh,
empty.
yeah, that is what the guarantee. Every pigeon hole contains pigeon means n is equal to m, right? At least m should be n should be m. Then only we could able to place one for each pigeonhole. So if n is less than m, what can be guaranteed is at least one pigeonhole contains zero number of pigeons. That's what we can guarantee. Similarly, whenever n is less than m, then at least one pigeonhole contains more than one pigeons. Okay, this is what the pigeonhole principle. And we have seen several examples related to this particular applications of pigeonholes where we can apply, like 1 to 8 we are having. From this 1 to 8 we have to choose any five numbers, then two of them will add up to 9. Okay, out of these five numbers, whatever we will be choosing, those will be having at least two numbers which will have the sum as 9. Okay, that is guaranteed. You cannot choose five numbers without having two numbers sum as 9. That is what the guarantee. So in order to prove that one, by using pigeonhole principle, what can be done is, first of all, we will be what you call forming pigeonholes. What are the pigeonholes? Like whatever the pairs which will make the sum as 9, those all we will consider as pigeonholes. Okay, like 1 comma 8. Okay, 1 comma 8, next 2 comma 7, 3 comma 6, 4 comma 5. These all we will be considering as pigeonholes. Okay, now from 1 to 8 we have to choose how many numbers? Five numbers. So whatever the number you will choose, that you put in corresponding pigeonhole. Okay, four numbers distinctly we could able to choose. Let us say one we will be choosing, two will be choosing, three, then four. Okay, one we will be having in first pigeonhole, yes or no? Because 1 comma 8, next 2 will be having in second one, so it's 2 comma 7, next 3 comma 6 we are having as the third pigeonhole, so it will be in this, next fourth one in fourth pigeonhole. Now fifth number, whatever the number you choose as the fifth number, okay, except these four, then definitely that can be 5 or 6 or 7 or 8, isn't it? So now 5 6 7 8, if you put 5, where we can put 5, where we can put 5, it should be in fourth pigeonhole. Then definitely we'll be ending with one pair which is having the hmm, which is having the sum as 9. What does it mean? It is again the principle of pigeonhole. More than one pigeon we are having in the same pigeonhole. That's what we can claim here, and we can prove this particular theorem. Understand? Yes, any doubts, ma? Yes, any doubts, ma? Yes,
Sir,
Maruti.
sir, yesterday
Ah,
we have got five numbers now, sir. In this question, 1 to 8 are chosen.
five numbers. That's what. Now
Yes,
also
sir,
five only. Hmm.
but now if we choose any two numbers from A1 and A2,
Hmm.
that can't match, that can't sum up to be 9 also.
No, no. I try to understand the question. I will be choosing any five numbers from 1 to 8. Okay, you can tell your five numbers here. Okay, and I am not sticking to 1 2 3 4 only. You can tell any five numbers. Then there exist two numbers, that can be first number and second number, or that can be first number and last number, or first number and fourth number. It can be anything, but two numbers will sum up to 9. This is what the claim. Right, now you read the question. Show that if any five numbers from 1 to 8 are chosen, okay, any five numbers you choose from 1 to 8, then two of them, okay, out of these five, two of them will sum up to 9.
9.
Now how we are proving is, what are the pigeonholes, what are the pigeons, that's what we are considering. Now pigeonholes we are considering as these pairs, like 1 8 which is summing up to 9, next to 2 7 as one pigeonhole, this has another pigeonhole, like this four pigeonholes we are forming. Okay, is there any other combination possible, like which will sum up to 9?
No, sir, it will
No.
be
So
9 and
four,
0.
yeah, four pigeonholes. Now how many numbers we have to choose?
5 numbers.
Five numbers. So five numbers, where whatever the number we will choose, that we have to put in corresponding pigeonhole. Like all 1 to 8 are present in these, all are covered in these four, right? 1 comma 8, 2 comma 7, 3 comma 6, 4 comma 5. In these four pigeonholes, all five 8 numbers are covered. So whatever the five numbers we will be choosing, correspondingly we will put it into corresponding pigeonhole. Then definitely without considering these numbers, just you consider four pigeonholes we have formed. Now how many pigeons we are having?
5.
Five. So at least one pigeonhole will contain more than one, right?
Yes, sir.
This is evident from pigeonhole principle. Now if we have more than one in one pigeonhole, when we will be putting into corresponding pigeonhole is, whenever 4 or 5 is there, then we will put in this particular one. So 2 will sum up to, this will sum up to
9, sir.
9, definitely. Suppose this particular pigeonhole is filled with 2, then definitely those two will be 2 comma 7, yes or no?
Yes, sir.
So definitely there exists a pair which will sum up to 9. This is what the proof. Got it?
Yes, sir.
Yeah. Next, similarly, another example also we have seen, like 1 to 20 we are having the set, and we are choosing 11 numbers from this. Okay, and what is the claim that we have to prove is, one of them, okay, out of these 11 numbers, one of them will be a multiple of another. This is what you call sorry, the claim that we have to prove. This is the proof. Now for this particular one, again, by using pigeonholes principle, we wanted to prove. So what are the pigeonholes, what are the pigeons? That's what we have to identify. If you identify those and model this problem as that pigeonhole problem, then directly applying that principle, there exists more than one pigeon with at least one pigeon with more than one, sorry, at least one pigeonhole with more than one pigeon, then this is the claim. Like that, directly we can argue and prove the required thing. So now consider this particular one. Every positive now, did you understand the question now? 1 to 20 we will be picking 11 numbers. Now what is our requirement is one of them will be a multiple of another. This is what we have to prove. Out of these 11 numbers, whatever the number you choose, that will be a multiple of another one. Okay, now you consider every positive integer can be written as n is equal to 2 power k into m. Let us assume n is what you call even number. Can we able to write it or not? Even number 2 into something, we could able to write it definitely. Yes or no? Any even number. Yes. Yes, Manohar.
Sir, can you repeat the question?
Okay, question. Okay. You consider we are having 1 to 20 numbers. From these 20 numbers, we will be picking 11 numbers. We will be picking 11 numbers. Then, out of these, in these 11 numbers, we will be having a number which will be a multiple of another number. Okay, which will be a multiple of another number. This is what the question. Understand the question?
Yes, sir.
Yeah. Now, in order to argue like pigeonhole principle, what is the observation that we are considering here is every even number can be represented as 2n. Yes or no? Or 2m.
Yes.
2 multiple we can write. So 2 into m. Let us say n is even number. Suppose n is odd number. Can we able to write it like this? 2 power k into m. If n is odd, if n is odd, let us say 3, 5, 7, like this, then k can be 0, right? Yes or no? If k is 0, then 2 power 0 multiplied by m. So in that case, n is equal to m directly. So any number, any positive number, we could able to write it as 2 power k into m. Even number, it is directly evident that 2 power 1 into m we can write, 2 power 2, 2 power 3, depending upon the number that we have chosen, we can write. Like 16, if you consider 2 power, if n is 16, how we can write n as 2 power k into m?
2 power 4.
Yeah, 2 power 4. What is the m value?
4.
2 power m value, m.
1.
1, sir.
Yeah, m is 1. Like that, even number we could able to write. Next, odd number, let us consider we are having 15. Then 2 power 0 into 15. Can we able to write on? Yeah. So like this, every number we can represent as 2 power k into m. Yes or no? Now, m can be odd number in general. M can be odd number. Like you consider 14, 2 into 7. Yes or no? You consider yeah, 12. Then 12 means how we can write? 4 into 3, right? So 2 power 2 into 3. Yes or no? 12, how we can write it? 2 power 2 into
3.
3. So this is m value, right? So m value always odd. If you observe anything, like you consider 16, 2 power 4 into 1, 1 is odd. Next to 12 we have seen. Next 14 you consider. 14, what is k value and m value?
2 power 1 into 7.
Yeah, 2 power 1 into 7. So k value is 1, m value is 7. So m is odd always. Now k is greater than or equal to 0. This can be seen by simply factoring all powers of 2, okay, out of n. Okay, this can you have understood how we could able to climb this one. Every number can be represented as 2 power k into m, where m is odd and k is greater than or equal to 0. Next, in this case, let us call m the odd part of n. Okay, we will call this m as odd part of n. And if 11 numbers are chosen from set 1 to 20, then two of them must have the same odd part. This is what the claim. According to this pigeonhole principle, we are trying to prove. So what are the pigeonholes that we are forming here is, whatever the odd part we have, those all odd parts we are considering as the pigeonholes. Okay, 1 2 3 so on 10. How many odd parts we will be having here is 10. Why? Because you can consider, you can write from 1 to 20. Just you please note down this particular point. 1 to 20, 1 how we can write in the form of 2 power k into m. Yeah, quickly you please write and tell. 1 how we will write? 2 power 0 into 1.
1.
Next 1 2 how we will write? 2 power 1 into 1. Okay.
Yes, sir.
Yeah, so m value is 1 in both the cases. Yes or no?
Yes, sir.
Yeah, next consider the second one. Third, number 3.
3. 2 power 0 into 3.
2 power 0 into 3. So m value is 3. M value only you try to note down. Next, for 4, m value is 1. For
2 square
5,
into 1.
yeah. For, for 5, what is m value that you that
5.
only you tell? 5. Next, for 6. For 6, m value is
3.
3. Next, for 7.
7.
7. For 8,
1.
1.
1. For 9,
9.
9.
9.
For 10,
5.
5.
5. Are you noting? Please note down all these values. Then only we can argue. Yeah. 10 for 10, the value of m is 5. For 11, what's the value of m?
11.
11 itself. For 12, we have seen. For 12,
3.
3. For 13, 13 itself. For 14,
7.
7. For 15,
15.
15. For 16,
2 power 4.
1.
1.
1. Next, for 17, 17 itself. 7. Next, for 18,
9.
9. For 20, for 19, sorry. For 19, 19.
19.
Next, for 20,
5.
10.
yeah, for 25.
5.
Because two, yeah, okay. So now, if you observe all the odd parts, what are the distinct odd parts that we have got? 1 we have got. Other things, you please tell. 3 we
1,
have got.
3, 5.
5, that's it.
7.
7. 9 also we
9.
have got.
9.
9,
11.
11,
13.
13.
13,
15.
15.
15,
17.
17.
yeah, 17, 19. Okay. Now, how many distinct digits we have got? How many distinct numbers we have got?
10.
10. Okay. Now, if you choose 20, okay, if you choose 11 numbers out of these 20, if you choose 11 numbers out of these 20, definitely we have to choose two numbers which are having same odd part. Yes or no? Screen is not visible. Oh, just a second, ma. I think Wi-Fi connection lost, but the wired connection is working. Yeah, now it came. Yeah, now it is visible, right? Okay.
Yes, sir.
Yeah. Now what we are saying is, whatever the odd parts that we have got, like 1 3 5 7 9 11 13 15 17 19, these all we will be considering as pgn holes. Okay. Now you pick any 11 numbers from these 1 to 20. Okay, we will put into corresponding pigeonhole with respect to the odd part that we have got. Okay, if you choose any number, you can say 11 numbers, we will be, we could able to select distinct numbers up to 10. Okay, into distinct pigeonholes, distinct odd parts. So 10 numbers we could able to select, but if you select any number as the 11th number, definitely that should go into the same pigeon hole where we have put already one number. Yes or no? Shall I repeat once?
Yes, sir. Please repeat.
Yeah, you consider, earlier we have considered this 1 to 8 5 numbers. In this particular one, what are the pigeon holes? This a1 a2 a3 a4, these are the pigeon holes. And how we will place into pigeon holes is, whatever the number we will be choosing, where we are having that that particular number, into that pigeon hole we will place. That was the um, modeling. Now how we are considering here the pigeon holes is, whatever the odd parts that we have got, distinct odd parts like 1 3 5 7 9 so on 19, these all we will consider as pigeon holes. Okay. Now if you choose one number, let us consider uh, 10. What is the odd part of it?
5, sir.
5. So into corresponding what you call corresponding pigeon hole, we will place that 10. Okay, 10 we have placed here. Next, now you consider another number like 12. What's the odd part?
3, sir.
3. So into 3 we will put 1 3 5 7 9 like this. Okay. Now you consider 15. What's the odd part?
15, sir.
Yes,
15 itself, sir.
15 itself. So we will place it in 15. Next, 17. At 17 we will place. Next, 19. At 19 we will place. Like this, how many we will be having is 10 we will be having here. So into those 10 we can place some 10 numbers without any conflict, without having two numbers in one cell. Now you consider any other number other than these. If you choose 11th number, definitely it should go into one of these 10. Yes or no? According to pigeonhole principle, at least one pigeonhole will be having more than one pigeon. Yes or no? So if you consider 20, what's the pigeonhole where we have to place 20? Where we have to place
5.
5,
In 5.
5. Why? Because odd part is 5. So into 5 if you place 20, what does it mean? Two numbers are placed in the same one, and these two will be multiple of another. Yes or no? 10
yes, sir.
20. Yeah. So that is what the claim. You consider any other number like 12 we have placed 6. Where we can place 6?
3, sir.
3. So definitely whatever the pigeonhole that will be filled with two pigeons, whatever the pigeonhole that filled with two pigeons, definitely that will be one of those will be one of
Multiple
those
of.
will be multiple of another. That is what the claim. I hope you understand the point. Yes.
Yes, sir.
Yeah. Yeah, Hafiz, any doubt?
No, sir.
Okay. Yeah, Jahnavi, is it clear? Jahnavi. Okay. Next, we consider another example which we have seen in the last class. I think this one is like we are having a hexagon, regular hexagon, where every side is same. That is 1 unit we are considering. Now we wanted to claim that if any 7 points are chosen in this region, then two of them must be no far than 1 unit. This is what the claim. Then for that purpose, we have to model pigeonholes, right? Like we have formulated pigeonholes like this here and here. Similar to that, we have to formulate pigeonholes. What are the how we will form pigeonholes? Is one idea is like we will be constructing six equilateral triangles. Okay, namely 1, 2, 3, 4, 5, 6. Now whatever the points that we will be choosing from this particular hexagon, okay, we can choose any from any what you call equilateral triangle. If you have any point within this, then it will not be having the distance more than 1 unit. Yes or no? If you have 2 points in the same equilateral triangle, then those two the distance between those 2 points will not be more than 1 unit. This is the observation that we can make. Now what are the pigeonholes? These six equilateral triangles are pigeonholes. What are the pigeons? Whatever the points
Points.
that we will choose, those are the pigeons. So seven pigeons we are having. How many pigeonholes we are having?
6.
Six. So definitely in one pigeonhole we will be having more than one. At least one we will be having with more than one pigeon. So whatever the pigeon we will be pigeonhole which is having two pigeons, that we can show as the evidence for claiming if any 7 points are chosen in this region, two of them must be within 1 unit distance. This is the claim. Yes or no? Is it clear?
So clear.
Yeah, just we have to convert this into pigeonhole principle. Just apply that, we can get the result. That's it. Like this, another example also there. You please go through this. Next, consider there exist more number of pigeons. Like earlier we have seen n and m, and now n earlier also we have assumed that whenever n is greater than m, then only we can say there exists at least one pigeonhole with more than one pigeon. This is what we have assumed. Now what is the uh, more what you call we can say how we can give more accurate information or more useful information rather than saying at least one will be having more than one. Like you consider an example, um, 15 pigeonholes we are having, then 16 pigeons we are having. Try to understand what you call reality. 16 pigeons we have, 15 pigeonholes we have. Then we can say there exists at least one pigeonhole with more than one pigeon. Okay, this is reasonable. We could able to argue. Okay, finally we could able to claim that. That is fine. But same context, but just I will change the number as like this. 15 pigeonholes we have, but 370 pigeons we have. Try to understand. 15 pigeonholes we have, but 370 pigeons we have. Now again I will say there exists at least one pigeon hole with more than one pigeon. Is it what you call sinking to the reality? Although it is true, that is not much useful. Yes or no? Try to understand the point. Shall I repeat?
Clear, sir.
Yeah, Maruti, shall I repeat, ma? Okay. Now you consider we are having five pigeonholes, six pigeons. Then we can say at least one pigeonhole will be having more than one. That is okay. It is what you call meaningful or useful information we could feel. But we are having five pigeonholes only, but 500 pigeons are there. For five pigeons, 500 pigeons are there. Definitely what we could argue, what we can say trivial, right? There exists at least one pigeon with more than one pigeon, one pigeon hole with more than one pigeon in it. It is trivial when we consider 500 with 5. Then what can be the what you call meaningful or useful information that we can draw from this observation? Same pigeonhole principle only we will use, but that observation is not usable, what you call very much useful. That observation what we are making is not very much useful when we say at least one will be having more than one pigeon. It's not always usable. But what can be useful thing is at least how many what you call pigeonholes will be having these many or something like that. Some according to the number of pigeons that we are having, 500 if we have at least 5 we will be having with these numbers, or such kind of information if you able to give, that is more useful there, rather than giving one pigeonhole will be having more than one. Okay, that is what the motivation for extending the pigeonhole principle. Just this is just straight extension. There is no what you call new concept, just extension of whatever the observation we have made earlier. Now you consider, yeah, before going to see, I wanted to introduce one thing, like let us consider 10 by 3. Okay, now what's the value of 10 by 3? Hmm. What's the value of 10 by 3?
3.3.
3.33. 10 mod 3. What's the value? 10
3.
mod 3. 10 mod 3. Mod.
1.
Yeah, mod operator will give you the remainder. So 1. Next, 11 mod 3.
2.
2. Okay. Now, you are in one room. Okay, wherever I am assuming that you are in one room. Okay, you are here. Let us assume you are in this particular room. Now, what we call this one? Hmm. You will be whatever the top you have. What we call that one? Hmm.
Roof.
Roof. Other words,
Ceiling.
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 Yeah, yeah. Let us assume this as the ceiling. Next, what we call this one?
Floor.
Flooring. Okay, this is flooring. This is ceiling. Okay. Now 10 by 3 will give you 3.33 something. Okay, now if you are now let us assume you are on the floor. Okay, on the floor in the sense, when you stand here or sit here, what will be the floor this one, and seal will be this one. Let us assume you are on top of what you call a table. Okay, on top of table, then you are here. Then what will be the floor for you?
Table.
No, no, floor will be same, right? This only, right? Floor.
Yes,
Flooring
sir.
will be, your flooring will be here only. Next, ceiling will be here only. Try to understand why I am discussing this example. It will be useful, even though the concept is known to you. This you can utilize to remember forever. Yeah. Now you are nearer to the roof. Okay, nearer to the roof. Now what will be your floor? The same. What will be your floor in the sense flooring will be same, although you are nearer to the roof. What will be the ceiling of you? Whatever the ceiling you have, same ceiling you will be having. Is it clear, this example? Yes or no? Yeah. Now you consider u as the number. Okay, 10 by 3, what's the number? 3.33. So that 3.33 is here. Okay, 3.33 is here. Now, what is the floor of 3.33?
3.
3. What is the seal of 3.33?
4.
4. Suppose let us consider it is 3. The number is 3. What is the floor?
3.
What is the seal?
3.
Seal is also 3. Next, 3.99. What is the floor?
3.
3.99. Yeah. You are nearer to the roof, still the floor will be same. That means 3.99 floor will be 3 only. Next, 3.99 seal will be
4.
4. Now you consider 3.01. 3.01. What is the floor?
3.
What is the seal?
4.
4.
4. Although you are nearer to the ground, ceiling will be same. Understand? So this particular example you can remember to recall what is seal, what is floor. In C or any programming language, you will be having this function: seal function, floor function. Do you know? Yes or no? Do you have idea about this?
Yes, sir.
Yeah,
Integral part we call it, sir.
yeah. So this seal is nothing but the nearest integer which is greater than the given number. Nearest integer which is greater than the given number. Seal of 3 means 3 only. Why? Because that is the nearest integer which is greater than or equal to the given number. Similarly, 3.01 means nearest integer which is greater than or equal to the given number. We cannot say although it is a 3.000001, then also seal will be 4 only. Why? Because whatever the number we have given, that number the seal should be greater than or equal to the nearest integer. Okay, nearest integer which is greater than or equal to the given number. That is what the seal. Similarly, floor 3.9999 so on, 10 times 9 if you put also, see floor will be 3 only. Understand? Why? Because the number nearest integer which is less than the given number. That is what the meaning of seal and floor. I hope you understand. Yes? Any doubts?
No, sir.
Okay. One last question. Seal of -3. What's the value?
-3. -4.
Seal of
-2. -2. -3 itself, sir.
-3 itself. Why? Because that itself is integer, right? -3 itself is integer. So it is fine. -3.2. Then
-4, sir.
-3.2. Seal of -3.2.
-3.
-3. The nearest integer which is greater than this. -3 is the number -3 is greater than or equal to -3.2. So such kind of number we have to choose. Understand? Don't be confused. Just you assume this room example. This is the seal. This is the flooring. Then the number, whatever the number you have chosen, like -3.2. -3.2 on top, like graph you consider. On top, what we will be having? This is the graph. Let us say -3. Here we will be having -3. Then here we will be having -4. Nearest integer which is greater than the given number. Greater than the given number means this one, that is ceiling. So -3. This is the answer. The nearest integer which is less than the given number, that is -4. That is flooring. Floor of -3.2 is -4. Seal of -3.2 is -3. Okay. Okay. It is not much what we call direct concept which we need to discuss here. Just as context came, I wanted to discuss. Okay, now whatever the seal and floor we have, mathematically these can be represented as like this. Seal can be represented by using this particular symbol, floor can be represented by using this particular symbol. This is floor. Okay, you can understand from these intuitively also you can understand. This is ceiling, this is flooring. Okay, now if I say 10 by 3 seal, what is the value?
4.
4. Why? Because 3.33 will be getting seal of 3.33 is 4. Similarly 10 by 3 floor is
3.
3. Yeah. Now you consider extended pigeon principle. According to the discussion which we have made, 500 pigeons are there, 5 pigeon holes are there. Then what can we say? What we can say about the pigeon holes and pigeons? This is what the intuition we have discussed. If n pigeons are there, okay, those are assigned to m pigeon holes. Then one of the pigeon holes must contain at least these many pigeons. This is what the observation. At least one pigeon hole, okay, one of the pigeon hole will be having at least these many pigeons in it. Okay, let us assume this 505 number. Then what's just to substitute in this one, what's the value? N minus 1 is n minus 1 is 499. Next by m, it is nothing but 5. Yes or no? Now floor of this particular one plus 1, what's the value?
100.
100. Why? Because this 499 by 5 floor is 99 plus 1, so 100. So at least one sorry, this is plus 1, so it will be 100. So at least one pigeon hole will be holding 100 pigeons. Okay, now can you argue without that? Like uh, how we could able to prove this one? That is what the statement. Suppose 5 pigeons are pigeon holes are there, 500 are there pigeons, 500 pigeons. So let us assume here we have will be putting 111 again 111 like this. If you keep on putting, then we have to put let us assume uniformly we will be putting 99 99 99 99 99. Then we will be accumulated to we will be completing up to 495. Yes or no? 99 multiplied by 5, so 495. Now we have to, we are remaining with, we are left with 5 pigeons. If you put those 5 pigeons in any of these, then definitely we will be getting 100. At least 100 pigeons we will be having in at least one pigeon hole. Is there any other counter case that you can give where this particular statement is false? Yes, any counter case that you can give? Like you can argue like I'll put all 500 in one, I'll put 200 in one, remaining 300 I can distribute to remaining 4. Like this you could think. But what is the statement? At least one pigeon hole, one pigeon hole will contain at least 100 pigeons. Now if you consider 200 in one, then that is the evident, right? One pigeon hole contains at least 100 pigeons. 200 if you have, then also it is true. 500 if you have, then also it is true. What is the what you call possibility to make it false is we should have in all the pigeon holes, we should have less number of pigeons than 100. Okay, less than 100 pigeons if we have in all the pigeon holes, then we can claim that whatever the statement given, that is false. Understand? Yes, could you able to follow?
Yes, sir.
Yeah. Now you consider 505 like this only. if all the pigeons holes are having less than 100, let us assume 99 only we are having in all, then 495 only it will accumulate. So we will not be assigning all the pigeons to pigeonholes. So it is contradiction. So this can be proved like this, proof by contradiction. We have seen the method of proof. One of the methods of proofs is proof by contradiction. That is, we will assume something and we will arrive with the contradiction. Then we can claim that whatever the statement we have taken, that is false. P is true, we will assume. Then we will say P is false. We will get contradiction and we will say P is false. Then negation P is true. That's what we will claim. Okay. Just you can recall with this. Yeah. Now if each pigeonhole contains no more than this particular one, this is what the assumption, not more than the given number, then there are how many pigeonholes that we have? How many pigeonholes we have?
M.
M pigeonholes. So total number of pigeons can be maximum m times this particular one, m times n minus 1 by m. Then it will be equivalent to m multiplied by n minus 1 by m, which is nothing but n minus 1. Now total n minus 1 pigeons only we have got. But how many pigeons we have?
N.
N pigeons. So we are, when we have all the pigeonholes assigned with not more than these pigeons, these many pigeons, then we will be assigning only n minus 1. But how many pigeons we have? N pigeons, which is a contradiction. So this contradicts our assumption that n pigeons are assigned to m pigeonholes. This is contradiction. Now what we can assume, what you can consider is negation P is true. What is P actually? Not more, no pigeonhole contains more than these many pigeons. That is false. So what is true? At least one pigeonhole will contain, okay, one pigeonhole contain at least these many pigeons. This is what the claim. Understand? This is the proof. Similar to that, we can see the example. Yeah, 30 people are there. 30 people are selected. Then we may choose a subset of 5, so that 5 are, yeah. This is what, like, we are having a month. Let us consider we are having a month, or you consider 30 people we have chosen. These might have born on different days, like Sunday to Saturday. Then if you consider any subset of 5, any subset of 5, then all 5 were born on the same day of the week. Those 5 can born on the same day of the week. This is just what you call substitution of this particular formula, n minus 1 divided by m plus 1. These many pigeons we will be having in one pigeonhole itself. So what is n, what is m? Yeah, can you tell me what is n? N is nothing but 30 minus 1 by what can be this one? 7. What's the value of this? 30 minus 1 divided by 7. What's the value?
4.
4. Okay, plus 1 we have, right? So plus 1 means 5. So at least 5 pigeons we will be having in one pigeonhole. That's what we can claim from this. What is this 7? Because for week we will be having 7. That's why 7 days. So that's why I have divided with 7. Okay, those many pigeonholes, 7 pigeonholes. See, the example we are considering here, we are converting as pigeonhole principle. And what are the pigeons? Whatever the days that we have, those will be the pigeonholes, sorry. And people will be pigeons. Then if one person got have born on Sunday, we will place into Sunday pigeonhole. Similarly, Monday, Tuesday, like this. Then if you choose 30 people, definitely there exists one pigeonhole. Okay, one pigeonhole which contains how many? which contains how many? At least these many.
5.
5. Yeah. So that means, what does it mean? 5 people are born on the same day. That is what the claim. Clear? Yes. Any doubt, ma? Yes. Any doubt, ma? If you have any doubt, you please tell. Or shall I
No,
repeat?
sir.
Okay. Next, another example. Last example. 30 dictionaries we are having in a library. A total of 61,327 pages. Okay, then one of the dictionaries must have at least 2045 pages. This is again a substitution of this particular one, that is n minus 1. What is n here? This one. N minus 1 is 61326 by what is m 30 dictionaries, so m is 30, so we will be getting 2045 pages. So at least 2045 pages dictionary there exist. That is what just a simple substitution. If you say um, for the same context, 61,327 pages are there, 30 dictionaries are there. Now I will say at least one dictionary will contain 2 pages. That is not at all useful. Yes or no? Try to understand my point. Yes. If one dictionary contains more than one page, then it is of no use. But if you say at least one dictionary will contain these many pages, okay, minimum of these many pages, then it is useful. That's why we are having this extended pigeonhole principle. I hope you understand. And yeah, right. Thank you, ma. You can enter your roll number and can leave. Thank you.